Hello, my name is Austin Smith, and I will be reassessing over Standard 1 Science Practices Test. I will be reassessing over Level 3 and Level 4 standards. I'm messed up on the slope problem. So instead of calculating the slope itself, I used data, which is not allowed. So when I went back over the slope for questions 4, which is when a student was given a task to determine the relationship between mass and volume for regular shaped samples of aluminum metal. I went back over it and I used what I estimated to be because uh, the data points in the ink was kind of hard to see. 15 minus 0 using the original point of the trend line divided by 4.75 minus 0, which got me 3.16, and then that formula the formula for that for the slope formula is y equals 3.16x, and then uh, I was supposed to find if the student had a metal with a mass of 76 grams, what would predicted metal volume be? So over the test, I think I just kind of blanked out on what I was supposed to do, but I'm just supposed to put in 76.7 grams, which is y back into the formula. So putting 76.7 grams into y, got, which into y would make you have to divide that by 3.16, which I got 24.3 centimeters cubed. For the next reassessment, I would be reassessing over level 4 standards with over analyzing and drawing a conclusion using CER format with in response to the temperature effect and volume graph. And for uh, for that one, I stated the temperature and volume have a direct relationship. That's my claim. As the temperature rises at around 23 degrees Celsius from around 4 degrees Celsius, as the volume also increases from around 3 milliliters to around 13 milliliters. This is evidence. The increasing of volume and temperature simultaneously displays the direct relationship and how they rely on each other's numerical status to either increase or decrease. For example, from the graph, if a temperature increased, so would the volume, taking from this the possibility that a similar action of decreasing would occur in reference to volume temperature decreasing, so with the volume. I will be also going over writing procedure for the same graph. So, in your laboratory, fill a graduated cylinder with 100 milliliters of water and place it on a Bunsen burner. Also, take a thermometer in Celsius and drop it into the water. Write down the room temperature, water, and volume. Then turn the Bunsen burner on and look for a stooping meniscus. Write down after a minute of turning write down after a minute of turning the Bunsen burner on the meniscus mark and turn off the Bunsen burner. The next problem I'll be going over was to interpolate and extrapolate information of the slope on the graph provided. So I said we could extrapolate the temperature of the substance when the volume is at 80 milliliters and divide it by 1.28, the slope of the trend line, which is 62.5 degrees Celsius. To interpolate the graph, I could find the volume with 25 degrees Celsius by multiplying 25 by the slope again, which is 1.28, and I got 32 milliliters. Interpolation is finding a point inside the uh, calculation of the slope and putting where it would be. So, like for example, if I used, which I did use, 50. Well, I used 50 temperature, 50 Celsius, which is the x-axis, and 39 Y. I would have to find something in that, which is why I used 25 degrees Celsius. That within 50 to 0. And then to extrapolate, that's something beyond that. So that would be something 50 to infinity or 0 to negative infinity. And for that one, I used 80. Uh, so, yes, that was my reassessment.